Hello everybody, welcome to another stream. How we doing? So today we're just working on, hang on a minute, let's open up. Forced to close some of these terminals. There we go. Right. So we're currently working on the occlusion culling code. We have been getting the occlusion culling in because we're trying to render a big old map, which is 1024 by 1024 by 64 or something like that. So pretty big map. So you can say like each block is probably a kilometer or something. Sorry, a meter. So it ends up being like a kilometer square kind of. So okay, I broke my build now. Yeah, effectively we're just trying to get the occlusion culling working, which would be super great. So we can just, the game can just be like, right, I got this big old map. It will try and do some culling around the frustum to be like, right, these chunks are what we want to send to the renderer. But the renderer gets a big old list of stuff to render, and it's able to occlusion cull lots of instances basically, and then render a smaller set of it. That helps with performance, and it helps us so we can scale up to a big map. That's the idea. Let's post that we're live. Pop the chat out on my laptop. And then right, we'll do a prayer, and then we'll talk about where we were last stream, where we got up to. We're getting very close to getting something working, basically. Right, Father in heaven, we thank you, Lord, for this day. We bless your holy name. Thank you, Lord, for being our great provider. Thank you, Lord, for all the blessings you've given us. Thank you for, our homes, our family, the peace that we have. Other countries are in a lot worse situation than I'm at least, and where a lot of my viewers are. So we just thank you for where you've placed us in this life and everything you've provided for us, Lord God. But yeah, Lord, I just pray you help me with this project, help me go down the right path, and we'll go down paths of righteousness for your name's sake. Don't lead me down into paths which end up bringing no fruit, Lord. Pray that every direction will yield fruit in my life and will yield fruit in other people's lives too. I pray for your wisdom, your spirit of wisdom, counsel, understanding, might, and fear of the Lord. I pray for a fresh outpouring of your wonderful Holy Spirit upon my life and my viewers' lives as well. I pray that each one of my viewers gets to know you, Lord God. So keep drawing them in, putting the people in their lives, and if any one of my viewers are not saved, Lord, that you bring them to salvation before it's too late. Thank you, Lord. And for every one of my viewers who is saved, I pray you elevate them in their walk with you, and just draw them closer into you, Lord God. Thank you, Lord. We bless your holy name. In Jesus' name we pray. Amen. Cool. Right, so yeah, effectively my third-party repo. So I host my repo on GitLab basically. It's 5 gigs free for each repo. I've got a separate one where I put all the third-party stuff because it's typically just a big load of stuff. Anyway, it's kind of broken a bit. Yeah, it was. I made some changes and I didn't update my build scripts. I didn't fetch the last one, and I don't use sub modules because sub modules are terrible. So I try and like manually clone it and stuff like this. Um, so this is not currently on a branch. Right, let's quickly fix this build script and then we'll talk about what we're doing today. So read out the repo hash. What is the repo hash? Oh, I see. Yeah, plenty of room. Oh, it's a char, isn't it? Let's try that out. Yes, if they're not equal, you're telling me they're not equal for some reason. Right, so it returns 1. So there's a difference somewhere along that string. I don't see it though. Maybe it's not null terminate or something like that. Yeah, okay. Seems like this is not doing its job properly. Basically. So if I string length it, so just string length it and just check the lengths. If they're the same, I'm questioning it, but if they're different, then I think I know what the problem is. Yeah, they're different, right? So let's summon up with it. This one's doing a chart, one more char than it should be. So read file. Plus cursor. Is oh, there's a new line in it. Crazy. There's a new line. That's not what we want, is it? So right. So yeah, it's going to be putting a new line in there. So we want to remove that new line. So what would be nice if this returned standard out size. That would be quite nice, wouldn't it? So where we got cursor. Okay. So what we're thinking about doing is simply, you know, there's going to be a new line there, but I guess we can just do it like this, right? So we can make it a bit more readable. Just say if hash -1 is equal to a new line, then make it into a null term. And that'll do it, I think. Come on, why are you complaining? Oh, it's in the header file, isn't it? Oh, come on. Amazing. Right, that ought to be good enough. There we go. Game's running again. Cool, I'm happy with that. So, now the build system's sorted out. Let's start, eh? So, basically, we have this block here. We did have a wider map, but I've just commented out that code for a while. And we're trying to procedure generate a map that's going to be 1024 across the floor, and then maybe 64 up and down type of thing. So we're trying to work on occlusion culling, so we can render a whole bunch of objects, no problem. And we've already got frustum culling, and we're currently trying to work on the occlusion buffer approach. The idea is you take the depth buffer from the previous frame and you put it into this texture called the occlusion image or something like that. And the idea is you downsample this image the whole way. So when you try and render a whole bunch of objects for the next frame, you take all of those instances and you find the rectangle that fits around. You find the rectangle which fits around the object that you're trying to render. You then find the MIP map where that rectangle is going to be a 2x2 set of pixels, and then you sample that texture, and that will get you a rough depth for one texture sample for each instance that you're trying to render. And with that, you can basically discard. You can discard things which are definitely obstructed by the depth buffer from the previous frame, but what will things which will roughly be visible, those ones will render. And yeah, so after we've rendered out that list, we'll generate a new depth buffer for this frame. But we haven't rendered all the objects still because some objects failed the occlusion buffer testing. So what you do is you basically go over it a second time, but using this frame's depth buffer. It's called a 2-pass hierarchical Z buffer, basically. sorry, 2-pass hierarchical Z buffer occlusion culling, something like that. And that's what we're trying to implement today. So we've got the occlusion image. We've got it down sampling fine. We are trying to get the screen bounding box of this instance. Once we have that, then we can... Yeah, once we have that working, then we should be able to sample from that image and basically see if this is occlusion cold, which is great. So then we'd be able to build a wall, and we should be able to see if the object behind the wall gets occlusion cold, which would be very great. So this is the function which had the problem. It had an issue because... So I was printing these boys out. All right, let's have a look at them. So print... So I've just got some quick and dirty print functions. So we can see the values. And there's only one object being rendered right now, so it'll be fine. So I was looking at these last night, these vectors, and I was actually drawing them as well, using our lovely little API. And I was seeing they were perpendicular to each other, these basis vectors. But I was looking at these numbers, and I was thinking, how are they perpendicular? But I was just looking at this X value and just kind of ignoring that. And I was just seeing the signs are flipped. So my brain just assumed they'll be pointing in the opposite direction along the X, but they're still perpendicular. What are we trying to find? It's Milton. That's the one. So effectively, the camera is rotated 45 degrees up and 45 degrees to the left. So essentially, when you take, so you got this box, right? When you look at it straight on, it might look something like this, right? So it looks something like that. But when we rotate the camera, it looks like what we have here. So when I take the basis vectors of getting this into view space, right, bear in mind the basis vectors for this is going to be one to the right, be one to the right, one up, and one going straight forward, yeah? One up, one going straight forward, you get the idea. The basis vectors here will be going one to the right, so like this, one to the left, and then one up. So what we're seeing is these numbers are referring to that. So you've got negative 0.707 and a positive version of that. And yeah. So they are perpendicular. So the issue is when we added these together, it made 0. And I think we might have to absolute them, but I'm also not sure at the same time. Now I was looking at this in the AI yesterday, and it was saying we could do it this way. Let's do the minimax A and BB. I want to do each corner just in case. But it seems to think... Yeah, so we take the ABS of this. I think we tried it though the other day. We tried it yesterday. And was getting a 0 in the X, basically. Oh no, we're not this time. Amazing. Right, so now we're getting a proper one here. But why then is my box still like a pixel big? You can see it, right? It's just a little dot there with debug drawing it. The box should be fitted the whole mesh. So if we look at P0, yeah, P0 is something now. This is great. So that'll be in view space. So look at P1. So if we get rid of these and so 1, 2, 3, 4, 5, 6, 7. I think that'll do. So it's the 8 corners of the box. So it seems like, yeah, the min point on the X at least is minus 1.4, which is right. This is fine. These numbers look really good. So when we divide those by Z, that'll get us clip space values. I want to look at those clip space values. So we're getting a min. Right, that's clip space. So what about in screen space? That's fine, I think. But it doesn't look it right, so what's going on? Yeah, it's only a few pixels. Something's off. So if we multiply this by 20, does it change? The answer is no. If it times by 200, does it change? Yes. Interesting. So far you find in the max all the Z's, right? Then a min of all the Z's is your near, obviously. Yeah, so this is what we're trying to achieve, right? Is get a box, something like that, but this is terrible. We could just get a projection matrix, but this code was working before, I'm pretty sure it was. Let's take a look at the other code base. So when I did this, the sphere one was definitely working. It was done with the icosphere. So move it into the local. That's what this is doing. Then, yep. Now go over all the view space ones. Divide by Z. Then min and max, that's your clip space. Interesting. Screen from clip scale. Ah, we might be using the wrong thing. Right, I think when I ported this code, I haven't used it yet. So I've not used this yet in this code base. Screen from clip scale. Right, it's the wrong one. Whoopsie, we need to get that. Screen from clip scale. So from the CPU side, we'll sort that out. So that is scene dims near clip distance. Scene dims. So floating point. Scene dims Y. Divided by this. So that would be right. I'm glad we found that. I think that is the fix basically, and then we should have a nice box that goes around that instance in screen space. Right, unfortunately that's not going to hot reload because we changed the data structures. Right, it seems to be covering the whole screen right now. No biggie, we'll sort that out. Too big, but at least we got that sorted. It's because I times it by 200. So it's going to be 200 times too big. Hey there, Emma Delicia. Welcome. Welcome, how you doing? Delicia. Yeah, that's alright. Welcome, how you doing? God bless you. Yeah, that box doesn't look right, does it? It's clearly too big. So we just got to figure out why that is now. Interesting. Why does it only change along the X? It would be good to see those vectors in screen space. Can we get those vectors in screen space? So when you have this half vector in view space, we could I think we do the divide by Z still. And then you divide by Z still. And then do this function here. So screen from clip. So we just want to times it by this sort of scale. That's all we're interested in. So dot xy divided by view from local dot axis dot z. Then we just times by that, yeah. Right, so that would get you sort of like the basis vector x in screen space. So let's just try and debug draw that. We've got some lovely functions for that. Draw 2D vector. So draw 2D space pixel, and then you put in the position for this vector. So I'm just going to stick it at 0 in the middle of the screen. Well, that's not going to be in the middle of the screen, is it? I think it's, yeah, let's just put it a little bit in the how we're going to do it. Yeah, let's just put it like 200 in. We'll see how it looks. Then SS, that's the vector, basis vector. Then the color, Or the layer number, then the color. So we'll make it RGB A8 red, yeah? Oh, right. It's not vector 3 yet, is it? Right, that compiled. Right, depth. Oh, thickness. Right, I missed that. So the thickness will be, I don't know, let's say 4 pixels. Right, it's a bit big. But it's going in the right direction, right? I think. Yeah, can I like normalize that? Then times it by 20. Right, it needs to be bigger, clearly. 20 pixels ain't big enough. Yeah, so that's got the right direction, yeah? So you see, this is the x basis vector for this. It is going that way. So we get the other two. Let's move it a little bit further inland. So we'll just say 500. Right. So if we get the other two, so it'd be a y and then a z. And then you just do a 1 and a 2 and a 1 and a 2. And you simply just y, z, red, green, and blue. Ta-da! Yeah, these colors don't look very right. I wonder why that is. Let's go to the Draw 2D renderer and see what's going on. So basically this is in shader code and we just put it in a buffer somewhere and then indirectly using draw and direct, right? That stuff. It will dispatch a draw call basically to draw these later on. So in the fragment shader, I think the color's off. Sorry, we know the color's off. But why? So it's saying from Rex over 09 to P3. Should be right. Yeah, because we use the P3 color space, right? P3 color space, that should be right. Because it's Rec 709. Yeah, linear from sRGB. I wonder what happens if you do that. Nothing is changing. Oh, it's the AABB, that's why. Got a vector. Yeah, so I think we're already seeing with these, the up is the wrong way around. Compared to what is in world space. So I think this is... Oh, okay, this is interesting. So what happens to color in here? Oh. Color times 8. Oh. Interesting. Right, I see. That's fine. They just look a bit dark is all. Yeah, so I was trying to make them a bit lighter, basically. And I think because Draw 3D needs to do that, because it's... But that's because Draw 3D is drawn into the world, whereas this is drawn into screen space. Cool, back to where we were. So it seems like the Y is the wrong way around. You know, like, are you saying then, so if we ABS Y, we'll be able to know what's up and down, right? So yeah, going up is positive, right? So it's bottom left origin, as we know. So what makes the Y say that it's negative? Like, let's print out basis vector Y. So we get is positive. So you're telling me after we do some stuff here that it just becomes negative for some reason? How bizarre. Right, what's that now? Still positive, apparently. No, it's not compiling. Right, now it's negative. Right, what is Z? That would be a good thing to find out. -2. Why is Z minus... So do we have to minus... So if we did ABS Z, does that fix the problem? I don't know, it keeps the sign, right? Yeah, I think that makes sense. Anyway, so those basis vectors look good, right? So we've moved them from local into view and then into screen space. And they resemble this thing, right? The X goes that way, the Z goes that way, and the Y goes up. Bing. So that's good. Why then is it so, what's the way of saying it? So landscape. You know, we times this by 20 or whatever, you would see. Okay, let's not do that. Let's times it. Right, let's do something a bit fun. Let's say sine g time and let's plus 1 times 4 or something like that, yeah? What's your growing? So yeah, it seems to grow outward and then upwards. So something's really off. Gotta find what's going on then. Like, we're looking at those basis vectors, they look good. So we should probably look at the points. Right, so the points are all here. So we're looking at the min point and the max point in clip space. I don't really care about near and far anymore. So we get rid of those, I think. Let's get rid of near. So we keep near, we get rid of far. Cool. Yes, the thing is I did normalize these basis vectors. Maybe we should have done that. Oh yeah, they'll be the same length anyway. Yeah, why then if we change the size of these basis vectors? Yeah, it's because all right, I know. So the Z and the X and the Z are perpendicular, right? So this is going down the left, so we absolute it. So it's going to swap over there. So is it right? Yeah. So yeah, maybe we shouldn't be doing these 8-point ways. So the other way is min and max ABB. Maybe this will do it. Right, so maybe we can do half extent. Right, so let's put this back to what it was. So it's 2 times. No, it wouldn't need to be 2 times anymore. Nice. So basis vectors is the half extent, so you just call that let's call that dims, I guess. Half dims. So translation, rather be a min max. Min view space, max view space, yeah. So you would probably then just do min view space. The thing is, does this work with shearing though? No, it wouldn't, would it? So yes, the other way is you yes, this is what I tried to do, right? Before construct the 4 different offsets. Right, does something like that. Good. Okay, so we'll try that approach then. That's why I wrote this approach yesterday as well. So yeah, the basic idea is we want to get the corners of the bounding box, but just get the positive side. So how do we do that again? Oh, where are we going? Come on. Right, here we go. So your basis vectors, and then yes, they're your different offsets. Right, let's try that out. So let's name this a bit better. So just call it bx, by, bz. So bx, by, bz, okay? So then that's the translation. Now you get your corners. All right. Okay, so basis vectors, your offsets. Then, yeah, it's basically right. So you do your translations, just call it T, plus or minus offset, whatever, okay? So T is equal to uh, vector 3 view from local translation. Right, so we do 1, 2, and 3, then negative, negative, negative. Let's try that out. Right, that's looking better. It's looking a bit tall, though. Can you see it? But maybe that's the best we can get. See what's going on. So why is it tall? Can I times these by something like 4? Right, let's do that sine trick again. So we do multiplied by sine of time. So it gives us minus 1 to 1. We add 1, 0 to 1, or 0 to 2. Then we times it by 4, okay? So that'll animate it. Okay, so it seems like what we're getting is a... Oh, it's time plus. Whoops. Wrong way around. I think the whole reload's broke. Does that sometimes. Cool. That's where we're at. So it's times in it by 3. So times 3. So yes, it's moving from 1 times to 2 times. Now, it's growing in a linear fashion, right? That's cool. You know, it's not the... Sorry, it's growing proportionally, right? Each axis. So it's looking good. The bit that I'm concerned about is that Y. The Y seems a bit wrong. So what we can do is take the points and move all of the points into screen space and draw them as little circles on the screen. Yeah, that shouldn't be too hard. So we just take all these and we can make SS. So that's in view space. We then divide it by the Z, ABS Z. Oh no, they're already there. It's already done. So that's now in clip space. Then we do the whole transform screen from clip. And what do you know? Cool. So now we just want to get these. Let's start with 1 point. So draw a circle. The circle is going to be at position P0SS. And the radius... This stuff. Radius, depth, border thickness, yeah? Radius of... let's do 4 pixels. We could do more. Let's do 16. Depth, let's just leave it 1. Because there's layers basically if it's 2D drawing. And a border thickness. We'll just give an infinitely sized border. Yep. So we'll make those red, I guess. Right, apparently that's complaining. Find out why. Okay, so those need to be vector 2s. Right, so there's our point. It's a little bit too big. There's point number 1. It's growing with a box because we're telling it to grow. We go to that growing code now, make it plain and boring. So if we see the... Where are you at? Yeah, so I'll make it 16. So we'll call it Now, where's that AABB? That's the layer. I'm not sure why it's... Oh well. Okay, so... Yeah, I think it's... no, it is working. Anyway, let's just draw the rest of the points. Oh. Yeah, you know what? I think... Right, let's just debug draw them. Four, 5, 6, 7, yeah? There we go. Those points look very odd, right? So it's great to see the, you know, the min-max code working and all of that, but can you see the cube? It seems twice as big, right? You can see it now. You see the vertices, right? It's literally a cube, but it's twice as big. So what gives? Is so effectively is the mesh rendering code or whatever, the voxel rendering code, is that doing it half as small, right? Or is this code doing it twice as big? It's very bizarre. So the axis vector should be, this is the half dimensions, right? Yeah, I think that's fine. So let's pop over to the voxel visibility buffer vertex shader thing. So we take it from, so we get the snorm, right? So it gives you -1 or 1. Basically, this just gets you a box. And then that'll be 12 from local, then into view space. Right, there is a projection. Right, so I think what could be out of sync is the projection because we're not using the projection matrix in this going to screen space code, or we just skipped that. So yeah, say if we times snorm here by 0.5. Right, sorry, times it by 2. But yeah, you see it fits that box. You have to go to the VBFS, I think. But yeah, there's some inconsistency I can't tell. But then in scene shade, maybe? Yeah. You have to do... Yeah, so I don't think that's the problem. But yeah, if we were to let times these by 0.5, it will... Well, it kind of works. It's a little bit off even here. Dun-dun-dun. That is interesting. I don't think it would be times 0.5, right? Because my local space is minus 101. I think you... Yeah, you need to remove the 0.5, exactly. So it's not coming from there. So there's the division. I'm wondering if we're using the wrong... Yeah, I know what's going on, maybe. Right, the reason why they're slightly off is because this space here, pixel, is talking about the UI, I think. It gets rendered on top of the UI. Hang on a minute. So the dimensions here is going to actually be the UI layer. Yes, render 2D storage goes to the scene post-process image. So maybe not. So the dimensions are here. Yeah. Okay, so is the scene dims. My mistake. Right, so we talk about pixel. It's doing... Oh, interesting. P. Yeah, so that'll be 0 to 1, and making this minus 1 to 1, basically. Okay. That seems alright to me. So screen from clip scale. Ah, we could be doing this wrong. I think I know what the issue could be. So this scale might need to be half of this. Yeah, I think this is the problem. Boom. Bingo. So the reason is because we're talking about, this is technically correct. We're talking about going from the middle of the screen to the top of the window. What is that? We want that height, basically. Because this near clip distance is talking about... Right, here we go. So you got the camera going out into the scene. The scene's here, you got like a box, right? Then you got the near... You got the texture which like sits here or whatever. And that distance... based on the field of view, basically, this... so this distance here is called that near clip plane distance, and the same distance is also the height. Is also the height as well, yeah? So when you're talking about a scale to map this near clip, it's like you got to map it, so it's got to be half the pixel height. So that was the issue. Good. Right, so I think we've done it maybe. Look at that. We've got screen bounding volume. Oh, isn't that amazing? So now, this is where the fun begins. So we can get rid of all this stuff. These basis vector things and this drawing. Man, this would be so good. Here we go. So what you see now is this will generate us a screen bounds from a view from local transform. And this will debug draw it. Now I've got this is occluded function. So this looks up in that texture. To see whether something is occluded or not, basically. Yeah, so it gets that screen bounds. It finds the MIP level to sample at where it's going to be a 2x2. And it will then sample a depth, yeah? So we want to print these values out now. So we want to print out vector 2 bounds depth. So that's the depth of the object, a rough depth of the object, like the nearest point basically, and the occlusion depth, which is a distance where if the object is behind that, it's definitely occluded. But if it's in front of it, it might be occluded, but probably not. So then we should render it. And we're using the previous frames depth buffer. So what we're seeing is it got a 0. And I think it's because we are not clearing the image with the right value, basically. So then we should be storing infinite in it, I think. So if we find, this is some old code where I've done it before in the past. So we find occlusion texture. I think this thing gets cleared. Yeah, here, right? Do we still have that? Maybe not. Maybe I got rid of that. So let's say prepare. Um, yeah, it's doing a clear, but like the clear value is nowhere to be seen. So the value float x infinite e32, yeah. Um, Still a little bit funny. Let's take a look at that. Right. MIP level's 1, yeah, clear 1 MIP level. That's what you want. Alright, what else are we potentially missing? So yeah, there has been a copy depth from a previous frame. That's the issue. So copy depth from previous frame, then that would be 0. Wait. Is it 0? Is that why it's doing it? We could open up in render doc and probably find out that way. Yeah, so it's copy depth. So let's comment that out. Right, now it's saying it's infinite. Interesting. So this scene image. Right, so nothing got rendered. Um, oh, you know what we're doing? We're copying like... this is so silly of me. We're copying kind of like quantized, well, it's already quantized, but normalized depth values, like into the... Right, so we need a separate shader to copy it manually and modify it. So I had one in the past. Just gotta find it in Git. So it's this one. So git restore. There should be a removes one here. It's called copy layer depth. This is it, yeah? So git restore this guy. Now, I want to make sure I don't accidentally run that command again. I'm closing the terminal, going over here. Okay. So now I've got this sort of layer depth thing back. I've just got to change the name because it's terrible. Where are you at? Shaders. It's not copying from the layer depth. It's now copying. That's the one. So copy depth to occlusion image. This is it. We want this to be a compute shader though, actually. So we'll rename that as well. So where is there a simple compute shader? Well, it's not really. No such thing as a simple compute. Of course there is, but yeah. We just need this bit right here. So yeah, starting off compute shaders, if you want them to be fast, you got to do something like this, where you do a Morton swizzle. Right, so we need some kind of push constants, basically. Let's get those. Where's the occlusion image? It's not the useful one. Anyways, let's take something like this. So copy. So it's called copy depth to occlusion image push constants, yeah? R take to F. So there's the occlusion image destination, and the source is going to be the depth image. Let's do source. But we probably want to sample it, I think. No, we don't need sample, so no, you do need a sampler because yeah, texture, because it's a depth image, and I don't think you can make depth images storage. They have to be a texture, a sampled image. So I think that's it. And then right, so where have we done? So there's the push constant type. So where have we done some kind of texture? It's like a texel fetch. Yeah, see, I've already done it right here. This is when we're merging it into the layer buffer. All right, beautiful. So we want that. So yeah, do a linear depth from a raster depth. This is what we're missing. And then we want to store it. Here we go. Right, texel fetch, so source, and then DST. And there'd be like a copy dims as well. I completely forgot that. Here we go. Depth. R A2F. That's it. Cool, so just got to throw this into the what do we put it? So we put it in the X macro list of compute pipelines to compile. The build system will automatically pick it up, which is great. No need to worry there at all. Then we just need to launch that shader instead of the copy. So copy, yes, this did an image copy, but the problem is it was taking a depth buffer and putting it into an image, and it was just going to be a 0 in there rather than an infinity. So we need to launch a new compute shader instead. So effectively, you just want to do something like this. And so it'd be known as copy. IntelliSense didn't want to help me out there. Anywho, so there's a kind of like as a texture, that's for sure, that is source. Occlusion image, beautiful. And we want to do another one called depth. Sorry, DST. Image 2D right or right only are oh sorry, this one's the occlusion image. This one would be the visibility depth. Yep. So then we want to take the dimensions of this thing, which is actually just scene dims, wherever that is. GFX VK scene dims.xy. Okay. Right, so now we just do a divide roundup of a pcdims.x, and then we just got to use the right pipeline. There we go. So special pipeline. Cool. So that should make it work now. No. Right, why wasn't this? I could. We should be putting this in GPVK. Right at the top. Just make everything use the extensions. No worries that way. Alright, here we go. Come on. Oh, okay. Yeah, right only. That's why. All power. All glory. Crap. Why? I think it's always got to be a Vec 4 for some reason. I think that's just the way this works. And it is, right? Yeah. Right, cool. It's now working. So, what we're getting, this is a great place to be at. Here we go. So here's the occlusion image. Yeah, it's white because that's infinite. And then we've got the closer stuff here, which is darker, right? Not sure what this bug is. It's really bad. I think it's the thumbnail code. It's just so strange, though. Anywho, but yeah, here it is. So essentially what we're doing is we're getting this screen box. We're finding where this box would be 2 by 2 at a certain MIP level. I don't know, let's say it's this one. Yeah, let's just say it's this one. So it'll find like a 2 by 2 on here, it'll sample it, and then get the depth, which is 60, meaning that it's the far plane, and it will it will say, right, my object here that I'm trying to render is at depth 28. Is this less than what is found in the depth buffer? And it says yes. So now it means you need to render it. So it renders it, right? So now the thing we want to try is we're going to build a wall, and the wall is going to be in front of this box here. And we're just going to see if it gets occlusion cold, basically. And we can do camera freezes and stuff to rotate the camera to see if that's the case. Okay, very good. We're getting close. Then after that, we've got to do a 2-pass system. Right, I'll be right back. Welcome back, everyone. How's it going? So, now it's testing time. We're going to go over to the game. We're going to build a wall. And we're going to see if the wall occludes a block. And the block disappears. And does not get rendered. It's going to be cool. So we look for logic render. Okay. And this is simply the block in question. And we'd like to render a wall. So we'll render it going along the X or the Z. Either will work. Let's just do it across the Z since we're here. And the other one will be a Y. So the Y would be going from 0 all the way maybe to, I don't know, 10, potentially. The idea is we'll put it X minus 3, I think. And let's give that a go. Oh, why did I put 0 though? Let's put Y. Right, so we should see a nice wall. Ta-da! So we're seeing a whole bunch of debug drawings of these things. Not very nice. So it's so we go to the occlusion culling. Okay, here's how we're going to tell. If it's occluded, oh no, some of these things are getting occluded. No, it's already failing. No. Right. But yeah, the idea, right, is you'd only see if it's not occluded. But then we'll say, hey, if instance index is equal to 0, then do that. So I'll only draw the first one up here. Yeah. Ta-da. Cool. So same here, right? We'll print out the depth value, providing that it is the first instance. Oh, come on. There we go. Nice. So, and they're great. Look. Whoa. So you put it behind there and boom, it disappears. Now that's not being rendered. We could freeze the wireframe occlusion, they call frustum, debug frustum, bing. So this doesn't quite work at the moment because the frustum and the occlusion culling are not in the right place. Plus, obviously, it's pretty crazy when you move the camera, but we'll sort that out. So from here, it should be blocking, right? So this should disappear, providing we use the right view matrix. Let me find it. So we should be using the view from world. We should be using is there's one called like occlusion. So if I go to like frame in it, I think. Yeah, the occlusion view from world. That's the frozen one. And all power. Is there any other view from worlds that we're using in places? So when we obviously render the objects, that in mind, they should be the same. Yeah, this is right. So with using this sort of frozen view from world, that's going to put it in. Ah, yes. But the depth buffer needs to also be from that angle as well. Yeah, so the depth buffer, so everything needs to be rendered as if it's from that oh, hang on a minute. So how are we going to do the occlusion? So I'm rendering it from this perspective, right? And it's obviously going to have a depth buffer in there and all of that. But I actually need a depth buffer from that frozen view from model angle. Sorry, view from world angle that we've got this frustum for. So like, do I render the scene a second time just to produce a depth buffer? So, so when you got debug frustum culling on, it will render. Oh, how do we do it? Yeah, I think you just have to render it to another. So you take the final render list and you just run over it again, but you do a depth only pass that chucks it into. Yeah, I think that's the way you do it. So if we go to, so copy depth to occlusion image, this is where the thing goes. So it's like G settings. If the graphics debug frustum culling, it's not really frustum culling alone though, is it really? It's, I guess occlusion culling we should probably call it. Okay. Right, so if this is enabled, you want to like render the scene as a depth only image. So we might need to make a new thing, like a depth only pass to render opaque voxels. And then the view from model needs to be using that occlusion buffer, like view from model, not the one that we're currently actually looking at. Man, this kind of sucks. Yes, there's no color attachment, just depth only image to this guy. So yeah, I get an idea what to do. So there's transparent voxels as well. You just do depth of voxels, you can call them. So no color attachments, which then means in turn that you need to do a new pipeline. Because you can always deal with more pipelines, right? And so it'll be this one, but right, voxel render VB. Voxel depth visibility buffer. It kind of sucks though because it makes it seem like it's like a legitimate pass, but it's really only used for debugging, but it's okay. So here we're just going to set spec color attachments to 0, and I think that'll be fine. So we find the depth pass here. Write the word depth. Oh crap. So when you do the second occlusion culling, you can set this indirect arguments up correctly. But we haven't done the second pass just yet. We're trying to get the first pass working fine. We'll do the second pass very, very soon. So no color. Oh, for crying out loud, this is the wrong one. No depth voxels. Here we go. So look for. Yep, they're fine. So look for render. So depth. We'll just use this pass here. So depth. Lovely. Right, so inside the indirect args structure, we're just going to do another one called depth. And for now, when we do the sort of voxel setup, we'll also do a depth one as well. But there'll be a second pass where this needs to be set to. Yeah, so when we do a second pass of renders, the instance's start index will need to be set to whatever this count was before, basically. Yeah. Sorry, we can sort that out. Right, so that should be the depth only pass. So when we got these occlusion cull debug basically, so debug occlusion culling. When we're doing that, we want to do this, right? Draw out into that depth visibility buffer. Just draw out into that the depth from that specific camera angle. Now, how do we get that specific camera angle in there? It's a very good question. So voxel render visibility vertex shader, it uses this sort of view from world here, yeah. But we want to be using the for the depth only pass, we want to be using the occlusion. And the push constant is way too big. But I guess what we can do, sorry, it's way too small for it to fit a whole thing in there, basically. So we effectively just say, is depth only pass, or is occlusion debug. Yeah. That's an occlusion debug pass or not. So this one will be yes. Whereas this one is going to obviously be a no. And then inside the voxel visibility, we select and get this thing. So it'll be, you know, Boolean of push constant, this guy. Like, is that view from world or the occlusion view from world? I think that's the thing. No, it's not. So it's occlusion. Yeah, now. Occlusion call. That's the one I mean. Yeah. So if it is, then we just not that. There we go. That'll be really cool. So hopefully that means we can now freeze the camera and spin it around and see something proper. So if we... Oh. Right, this is not in the right order. What do you know? Here we go. Right, so I'm going to move the camera. Now that thing is now not visible, yeah? Oh. Now we bring up the F1 menu. We find the occlusion debug. We turn it on. Now it's going to freeze the camera. Oh, it's working in it. No, it's not. No. Right, what are we missing? Oh man, this mouse stuff is really annoying. We should really fix it. So if we bring up the... So for some reason, the object VB image, the object visibility image, is that the right one? No, scene VB image. Right, something really fishy is going on. Scene depth VB image. Scene depth VB image. What was that in the what is this object? What is that? Oh yeah, sorry, yeah, that's the color. Oh yeah, sorry, it's the visibility buffer itself, right? Yeah, of course. Yeah, so why is it getting that perspective where it's drawing all the brick? That shouldn't be the view that it's... Oh no, sorry, that one's not being rendered. It should be the depth only one. Yeah. So I don't think... Yeah, so we want to be doing a clear and a store. We want it to be acting and behaving the same way. So we find this. There should be a few places where it's written to, right? Yeah, so the first time it's written to is there. That's the main render. And the second time is here. Oh, yeah, that copy depth should happen after draw 3D, but that's not the main issue. It's good to know it's... So it should clear and then store. Then it's doing a depth only pass. We're using this guy here. We want all of this stuff on still, right? We're using the same instances that we render. And render VB. Oh, so the fragment shader, is that not? Oh, the model from view, we need the inverse. Okay. Right, no biggie. Yeah, so we need, because it does a little ray trace in the fragment shader, of course. Okay, we found the problem. This is great. So inside the shared, well, there's a view from world. We also need a occlusion call world from view. So it's obviously just the inverse of that, yeah. So world from view. So it's a VB fragment shader. We want to get the matrix 3D of world from view. We say if it's not a boolean of is occlusion debug question mark G. So that's from the global buffer basically. Oh, come on. All right, that should work. Let's give it a go. So we move the camera, put it there. You see it stops debug drawing that white box, meaning that it's cold, yeah? Now, we take the, press the F1 key. We say, hey, I want to, debug the occlusion culling or something like that. We find it, turn it on. Now it should freeze the frustum there and allow us to move it. And what do you know? It's not there anymore. Wow. So that's cool. So it's actually being occluded by that brick wall. Amazing. So we see the textures now. So here's the scene. So here's the camera angle. Yes, here's the camera angle that we're looking at it from. But here's the camera angle that frustum's frozen at. And obviously the brick which is being occluded is behind there, which is cool. Right, so we know that it's basically working. This is great. I would like some of these tools to be a bit easier to use, but they at least are there. Yeah, we're seeing the edges are being frustum cold. I want to get this mouse thing sorted out. These fly controls. But yes, you see that. They be cold basically, like that. Very, very nice. Now, we got other problems, right? Should we take a look at those? So we turn off the debug. And you see what's going on. If you move the camera, it has issues. Why is that, you think? I can tell you why. So we're using the last frame's depth buffer to test whether this frame's information should not be rendered or not. Right, so this is what's known as the first pass of the two-pass hierarchical Z buffer occlusion. Now, so what we have is a bunch of objects which need to be rendered and ones which didn't. So what we need to do now is keep track of the ones that couldn't be rendered. And after we've rendered the first lot, it should be rendered, we get a new depth buffer. We then generate a new occlusion buffer from that, and then render all the ones which failed again and see if they pass. And then we won't miss any objects. You also have this problem, which looks very problematic. I don't know if that's going to be solved by the next thing or not. Oh no, it won't be. It will not be. Yeah, it would be nice to see what those rectangles are like, but you can kind of tell, right? They're just that. You know, I wonder if it's we can probably quite easily check this, right? I reckon there's an off by one error somewhere, so you can just fudge about with the results basically. So if you go to occlusion cull, like, are we maybe selecting the wrong MIP level? Can we just do this? Right, that made more fail. Can I select the next one up? That made more pass, I think. So it could be that we select, you know, you select the right MIP level, maybe that could be it. But then that doesn't even work until there, you know, so it makes it less effective, right? So that could be the problem. But I don't think it is, right? Because doo, doo, doo. All right, what else could we need to do? So you get the MIP. Could it be that we're taking the wrong... Right, should you be taking the max? Oh, no, it's the min. Yeah, sorry, of course, it's the min of the number of MIP levels, right? Yeah, changing that is going to be just like adding one to that kind of, but just a little bit more corrective, so. Yeah, so I guess you can work this out, right? So if the dimension is like 2, right, the largest dim is 2, so it's 2 by 2 pixels on the screen, right? The MIP you want to be using is 0, right? So if you find the most significant bit which is set, you'll have one, yeah, so if the dim is 0, then we obviously return. Now, if it's 1, the most significant bit should be 1. So that'll be 1 that we use MIP1. So it doesn't seem like it's doing the right thing. So if it's 2, You see, if the thing is like 1 pixel, do you really want to render those things? I think at that point, if the thing is like less than or equal to 1, you just don't really want to render it, right? Yeah. So then we can say, right, largest dim is definitely 1 or more. So if we take away 1 on it, yeah, it's questionable. So if it's got a value of 2, you take away 1, the most significant bit will be 1. So then, sorry, it'd be 0, wouldn't it? It'd be 0, perfect. Then you use MIP0, which makes sense, right? Because then it's a 2 by 2 at that MIP level. So then if your largest dimension is a 3, is 3, well, it's not a power of 2, is it? So it's going to be the same result. So this is where you can actually get a box, which is, it's going to be bigger than that 2 by 2 region, I think, on screen. And yeah, I wonder, do you want to use that or not? So effectively, if it's not a power of 2, you want to like add 1 or something maybe? That's my guess. Let's see if we just get some quick ideas. So for HZB, let's just say how do you select the MIP when you have a screen bounce? Let's say that. Yeah, so the goal is to select a MIP where your OBB mapped to an area. The goal is to select a MIP where the projected screen bounds of your OBB to an area no larger than 2 by 2. Yes, I think I might have to do a roundup basically. By doing this, you can safely query the maximum minimum depth of the bounding box with a single bilinear sample. Yeah, so log 2. Yeah, it's already done that, and that's like doing log 2 basically, right? Because you want the bounding box to fit comfortably inside a 2 by 2, often chosen MIP level, the formula is something like this. So max log 2 seal. All right. Yeah, we keep it as floating point, then we can just do round up. It's probably a wise idea. So, yeah, if we keep them as floating. Yeah, so you take your largest dim. So if it's less than 1, I might as well just not render it. I say less than 2. If it's less than 2 pixels, we might as well not render it. Then your MIP to be a seal of log2, largest dim. Cool. That looks all right. I don't know if that's failed now. Yeah, so right, the MIP is now low. So we want to U32 that, please. Right, so we're still kind of getting these issues here. I don't think it's as prevalent though. We can test that quickly by just simply undoing it. So it's tested out. Yeah, so it seems to have actually fixed some of them, which is super nice. So there's still some of them which got an issue. Are we using the right sampler, basically? I think we are. So, yeah, the reason why it's the sweet spot is it's conservative. Thanks to your conservative max sampling. Yeah, so right, here we go. This is what we want to look at. So even if your bounding box is smaller than 1 pixel, at a certain MIP, it might sit precisely in the bounding intersection. Yeah, we just don't want to bother rendering those things anyway, I don't think. Maybe. Yeah, there's no point. Because the thing you're trying to render is not going to fill that bounding volume anyway. Might sit precisely on the bounding intersection where 4 pixels meet. If you use a standard point sampler nearest, you need to read one of those. Right, what's this? It might sit precisely in the boundary between 4 sets of meat. Right, I see. Solution use bilinear with a max. This is what we're using. Do a gather and then do a max, right? Yeah, I think we got it right. So it's min max. Yeah, we just bottom left. Is that clamp the right thing you should be doing? Probably. Let me double check. Yeah, it is the right thing. Cool. Right, what else could be wrong? Yeah, so these ones are failing for some reason. Hmm. Maybe. So we've got this thing called an occlusion downsampler. This downsamples the image into that pyramid. Now, should it be doing a min? No. That looked kind of cool though, didn't it? Let's do it again. Boom. That's an obvious no. Do reduction max. Okay. So the sampler that we're using is here. No, that's the equal rectangular. That's for the skybox. Yeah, we've got the reduction max, right? So should we be doing reduction min? I don't think so, but we'll try it. Oh, why is that using nearest? Ooh, that's the problem. I knew it was linear, but yesterday I, for some reason, wrote it as nearest, maybe. It works. Look at that. Nah, but now this doesn't work. Oh, it does. Good. Yeah, it just depends how well the thing down samples into effectively, right? So the further the thing is away, the more likely it's gonna leak. Well, leaking is not the right word, but the more likely it's gonna um not have information in the lower MIPS because it's just so low resolution, right? And you need to be a 2x2 when it samples it. That's looking good. Amazing. So right now we can fix the other problems. So the other problems are obvious, right? You move the camera. Oh no. And that's because we're using last frames depth buffer. And this is only a single pass occlusion testing. We need to make it a double pass. So we're currently rendering out all the ones which are not behind that previous frames depth buffer. But now we need to do that check again after we've rendered the frame. We use the new depth buffer, downsample that again, and then do a second pass over culling for all the objects which failed. So this occlusion culling pass, it needs to have a friend where there's like a list, like a fail list or something like that. So I think we need to move this into a header file. So it's called the voxel, I think we'll rename it because I want to actually make this code shared between like other passes, like for meshes and stuff, and maybe the grass blades. And it would just be good if we had that all planned out. So voxel occlusion call this guy. So we'll call it a .inl. So glsl .inl, it means in line, right? CS glsl. I know. Just call it .h. Let's .h it. The other ones are called .h though. Yeah, let's do .i now because that's what these things mean. It means you're meant to inline it, right? Let's just call it .h. Okay, that'll be fun. So we'll just call that occlusion col. There's our boy. The basic idea is this now becomes absolutely nothing, but we define some stuff over it. So I think you just do dot occlusion col.h. Ta-da! And we'll put some defines in here. So we'll call this one the or you call it pass 0. We have pass 1. If pass has not been declared, then we've got serious problems. So we can do some errors. So let's go over to occlusion col.h. This code looks familiar. And we're going to find here. So currently we're going over all these sort of like voxel model instances. Now, if the pass, all right, if not defined pass, then we error. Pass must be defined as 0 or 1. Nice. Now, hopefully the GLSL-C compiler supports that. We'll see. It usually has a track record of basically, you know, not supporting stuff like that, but we'll see. So if the pass is equal to 1, we would like to read from a list of sort of failed instances, if you will. So the first pass should come along and instances to render. So if pass is equal to 0, we Okay, so we want to render out pass to render, sorry, instances to render, instances to not, to maybe render. So you put that out to the maybe render buffer, and then in the second pass you come along and try it again. So essentially, you want to, in the first pass, read out this guy. Read only. Instances to maybe render. and I would like to read out instance index. Okay. Now with this, we can set instance index equal to what we found in here. And then it will go and read it from the instance buffer and do all the frustum culling again, and then do the culling here. But what's also interesting to take note is we don't need to frustum cull again, because that, like, we should really need to frustum cull on pass 0, right? Pass 2, you don't need a frustum culling. So it's just this occlusion cull here. Then on pass, yeah, so then on pass 1, you'll basically append onto this buffer still. Yep, cool. Right, so there'll be 2 passes of that. Very nice. So let's go ahead and get the second buffer created. And so to render, instances to render. So these really shouldn't be part of the voxel cache, because it's not, the voxel cache is just meant to be sort of a manager for all of the state that we've loaded in from disk and all of this, right? It's not really to do with rendering the things, right? So I think this should come out to a separate place. So these are like runtime buffers. So it's to maybe render. Right, so let's find these guys. Oh, power. Here we go. Right, so we just find where that goes. So there's the histogram. I keep forgetting I have auto exposure. It's pretty nice. You kind of need, well, yeah, you kind of need it. Go ahead then. Right, to render. Nice. So then we have a maybe render array. Ta-da. So now you got that buffer. We now, not the histogram. Cool, so this is occlusion cull voxels. So you want to change this such that it does the maybe render as well. And you might as well just think on that as well. Well, no. Yes, this would be write only on the maybe render. And it's read only on the other one. So this would be the occlusion cull voxels. So prepare the occlusion culling. Then you actually do the culling. Hang on. The downsample. Yeah, it's still using last frames depth. Oh yeah. Yeah, so prepare would, so we'll probably have like frame in it. I've got these are all kind of inconsistent, but yeah, we probably want occlusion call, frame init, occlusion call, prepare, or downsample. The frame init, you know, I don't really care about that, to be honest. Yes, let's initialize the frame. Okay. This would be downsample. Then you want occlusion call voxels. Right, so just got to sort those out. So prepare. So you prepare it. You frame in it. Yeah, so frame in it. Occlusion call voxels pass 1. So I guess you put the pass number in there. So you can say pass and yeah, I'll probably just do a pass. So you just assert this to be less than 2. Now, you basically get the pipeline. VK pipeline ID, I think it just is one of them. So pipeline ID, so that'd be a, if you've got pass. So if it's 1, you want G pipeline ID. Now I've got to get these pipelines in actually. I haven't got the so occlusion call. So occlusion call, we can call it occlusion call voxels pass 1. Or 0 and 1. So occlusion call voxels 0 and then 1. So that will go into the internal. Right, sweet. So occlusion call voxels 0 and 1. Excuse me. Okay. So get your pipeline ID. I think the pipeline IDs. Yeah. So there's 1. And then what you also want is a if pass is 0, then the maybe render list is write only. But if it's, I guess we'll do it. But if it's the second pass, we actually want is maybe render to be read only. Cool. So now you got this lovely guy. So you got 0, 1, and then you render out your opaques again a second time around. Okay. So you need a downsample as well. You'll probably need to copy the depth copy depth wherever that's gone. This one. Now, we probably want something with this function we've got to do. Yep. Cool, so we could probably say occlusion call debug, probably put that into another function, just so it makes it a bit more easier to follow. So occlusion call downsample, whole voxels. So we'll call this one like occlusion call depth. Debug depth. Cool. Right, so why won't this work then? So you copy the new depth of the occlusion image, then downsample it, that's fine. You know, this should only really happen on the first frame. What are we trying to do? Yeah, the image should really be cleared to the value of like a value of float 32x of infinity, I think. We can test that out. But I don't think this is gonna get called twice, but maybe it's just fine, right? Doesn't matter. Probably okay. So rendering opaques for the second time isn't gonna work because so we need to set up the indirect. You know, we're doing draw indirect, right? So we're voxel render VB. So basically, I think in frame initialize, we want to, let's find that. Yes, we want to do like a voxel render. Okay, so when we do this sort of set up those indirect arguments on the GPU, you got the vertex count, the instances count. So we want to change the start index at some point. So yeah, I think, oh, what are you gonna do? Right, so we definitely need like a maybe render count. And in framing it, we need to set those both to 0. So the first pass, you want it to be that, but the second pass, you want this to be set to the old version, what this was beforehand. And you could probably store this and just call it old. And that would then be old is equal to this one. And then you store then you read make start index for that, right? So in frame init, the old should also be set to 0 as well. The first time it comes around, it'll set to 0 and span the whole thing. Second time it comes around, it does just the next portion. Now this voxel depth, we want it to do the whole thing because that's only for the debug camera when we move it. And freeze the frustum at a certain position to check the occlusion culling. Yeah, what else? So, old voxel model. Yeah, sync code, that's what I was thinking. So this needs to now be read write. Also, no, that's fine. I think that's it. That should be the two-pass system working, maybe. Probably got to fight some things, but that's programming for you. Right, what we got here? So, I think I pasted something over somewhere and it's like completely accidentally and it's busted something. Maybe. Maybe not. Yeah, okay, I didn't close these guys, so it's complaining about it. And now, right, pipeline ID is not a thing, obviously. Okay, so there was a, right, so it's a compute pipeline ID, that's what we want. One of them. But the IntelliSense didn't want to be helpful for some reason. Hey there, keeping track of this. How's it going, sir? How's your day? See, we could make it read write. Then that would also be very weird. Yeah, screw it, let's do read write. Yeah. Let's just make it always be read write. See, I wonder if the occlusion culling could... No, it's alright. Copy depth, that's the one I'm looking for. We need a bit of void in there. I like the concept of your game. I'm more of an Ephesians 6:10 to 8 to Iron Man crossover kind of person. Huh. Right. Not sure exactly what you mean, but I guess you're talking about like high tech. Yeah, I guess what you're saying is like when you read that you imagine like high tech. See, that's the thing, like you know, I think as Christians probably due to like, history and things, we think of the word spiritual meaning as something that's sort of like ghostly that you can't see and not able to grasp and but you know I, another way to look at it is just spiritual is like high technology, you know it's like you know angels are spiritual beings, and when you're I'm pretty sure it says in the Bible when you get resurrected in a glorified body, it's like a spiritual body, right? So it's kind of like a high technology body, right? So, you know, angels can manifest themselves in the physical and, you know, so that's one way, I guess, looking at it. But yeah, don't take my word for all this stuff. Read your Bible. Yeah, I'm doing alright. A little bit tired, to be honest, because, yeah, not been sleeping the best past couple of days, but, and my son's been waking me up early. But yeah, doing alright. Doing alright. You know, it's the weekend for me now, which is great. So, happy there. Got lots of house stuff to do, I'll tell you that. There's windows to clean, and what else is there to do? Yeah, things to clean, basically. Lots of cleaning, I think. Summer has made it apparent my house is dirty. So I'll look at that at the weekend. For small instances to render. Right. Cool. But yeah, we started working on the game like a couple of weeks ago. And what do you know, there's always some more rendering stuff to do. But you know, it's fun, and it means that we can build this map, which is like a kilometer squared. You know, not really fan of kilometers, but I'm using meters, so it's a kilometer. So a kilometer squared, and maybe 64 up, something like that. 64 meters up. Should be fun. A nice procedurally generated map, which would be pretty cool. And once we have a map, there'll actually be content for the game. Bam. We can make that look good. Good enough to build some gameplay. Have you watched there's a video on YouTube keeping track of this act? Have you watched the YouTube video? Maybe you have, because you said you like the idea of the game, but I don't know. I go over a bit more in detail on the YouTube channel. There's a video about it. Could not find the header file. Yeah, because it's named wrong. I think it's .cs basically. Right, so occlusion, that goes. Right, I see you. I know what's going on there. So this wants to be read write and read write. Bam, look at that. So it's working. Do you see it? We're doing 2 passes. You know what? I don't think it is working. Damn it. Because it's not culling the object anymore for some reason. But so if it's not culling that object, it means the so when I was moving the camera, it was getting like last frame step buffer culling a bunch of objects. So yeah, we gotta debug print this stuff and find out. We're very close. So we can bring up the profiler and have a look in here. Maybe this can help us find out what's going on. So it seems like it's the count. Maybe it's over rendering the objects or something like that. But yeah, so clear image, whatever that clearing means. Yeah, so downsample the occlusion image, polar voxel models, render setup, the visibility buffer, that's the first pass. Copy the depth to the occlusion image again. This time it's this frames 1. Downsample occlusion image, occlusion call, second pass. Setup, render. But this time this render is longer, which leads me to suspect it's doing too many. It's rendering too many objects or something like that. So what we can do is we can get rid of this printing code and log out some other things basically. Yeah, we can log out the numbers of how many are in the first pass, how many are in the second pass. All right, just going to take a quick break and then we'll get back to that. BRB. Right, welcome back everybody. Now, why is this thing so blurry? This is what happens when you buy an AI webcam. It's crap. The autofocus, when you have it on, doesn't autofocus too well. It sometimes goes unfocused and tries to focus again. And then when you stick manual focus on, the manual focus, if you stick it at 80, will magically change to where you need to change it to 140 or something like that after using it for a while. Why? I don't know. All for the sake and all for the name of AI. Piece of work. This is why I can't wait until Jesus comes. All these problems will go away. We can live in the garden, touch grass. You know, probably have a horse of our own that flies in the air. It'd be great. You know, the lion will sit down with the lamb. Good times. But until then, we live with AI destroying the world. Ugh. Here we go. All power, all glory to the Lamb. So let's print out some numbers. Numbers sound good, right? We like ourselves some numbers. So let's print out like how many we're rendering in the first pass and how many we're rendering in the second pass. So we literally just write the word print, and that'll go out to a storage buffer somewhere. Then the CPU goes, oh, I've got stuff to print out in the terminal, and then it goes and prints it out. You know, you can have printf and shaders. It's fine. Well, not really printf, but you can print from shaders. Possible. And it's handy. So what else we doing? Old, new. Yeah, so we'll just do 1, 2. We'll do 10 and 20. All right, here we go. So basically there'll be two 10s and 20s, right? It's a first pass and a second pass. So those are the numbers we thought they would be, right? They're like so 501. Oh, for crying out loud. Are we looking in the maybe list? Oh, I didn't put an if-else statement around. Instead I just did both. Right, so in the voxel, in the occlusion culling code, right? So basically, hang on. Man, things are so much better when you have go-tos. Go-tos are amazing. Anyway, until then. So you can call it if success or if you know, should render. And by default it is true, I guess. Should render is true. Then this thing comes along and should render is equal to, so if the OBB is in the frustum, yes, and we only want to do this on the first pass, yeah? Now, if we should render, then we want to try and see if we should not render. And we only render if it's not occluded. Then after that, this is just the debug box I'm trying to draw. Do we care about the debug box? Oh yeah, of course we do. Of course we care about this. We'll get rid of this in a sec. Same with this one. So it's just debug drawing that white box. So here we go. Right, it is simple. You know, if we had pointers, then you could probably just take that as a pointer and whatever, but now you gotta let the compiler do it. So hopefully the compiler does the job we want it to do. You know, it's one of those things. Welcome to shader programming. Anywho. Yeah, looks great, doesn't it? So if it should render, it goes into the should render pile. If it's the first pass, then if it doesn't go into there, it goes into the maybe we'll render a later pass. Nice. Cool. Anywho. And what we find out is stuff is now broken. No. So first pass 501. So where's the second pass? Oh yeah. I think we need to rerun it again from scratch. Right now it's all completely busted. Seems like it's now out of bounds. Oh. No, what have we done? Oh crap, what do we do? Oh, that's interesting. That is interesting. So the instances should actually be crap. It's got to be indirect kind of thing, isn't it? So I'll come from a buffer somewhere. So ooh, no, this is fine. So if the pass is equal to 1 to 0, sorry, that's what you do. If pass is equal to 1, you want to there's a maybe render, G maybe render count. Yes. Now the question is, how do you dispatch that properly? Yes, so it actually needs to be indirect. So when you do the voxel render, all right, let's go to shared. Right, so it's going to be a, oh, we need to get these from the, all right, let's go to the Vulkan header. Right, so it's called like, oh no, we don't need that. Okay, we just need one of these. Yeah, it's to be called Occlusion call dispatch. Occlusion call 1. I think. Yep. So when we do what's it called, render, voxel render setup, in here we can actually set this up. So that'll be equal to, and it's going to be equal to the maybe render list, isn't it? So you've got the maybe render count, then it's 1, 1. Now, I think you've got to divide it by 256, the number of groups. Divided by the number of groups, right? So if you go back to the CPU side, now I've just got to dispatch it right. So there's occlusion call. GPU program is so fiddly. Right, so occlusion call, something, what is it called? Voxels, yeah, this is it. So if it's the first pass, we dispatch standard. Second pass, we don't know how many instances that we're doing because it comes from a different buffer. So we use indirect, and the arg offset that we're using is offset of graphics vk indirect args, and it'd be called occlusion col 1, which we set a second ago on the GPU, yeah? Wasn't that crazy? Right, so if we go to that shader quickly, the occlusion col.h, is there any sort of like instances count that we keep looking at, or is that it? No, good. Nice. Okay, so that will help solve some problems, the fact that it's doing too many, but right now nothing is rendering. So it seems like it's trying to render though, because the first time it's got 0 for the start index, and then for the end index, or for the count, it's 501. Second pass, it's got no more. So why do I see no objects rendering? Is the question. We should be seeing them. Oh yeah, but if we move the camera, they'll work again, isn't it? Oh yeah, I remember that. Good times. So so we go to graphics VK, let's find the so what happens if we don't do this? Right, we just render one pass. Right, we just render one pass, it works. Doesn't do any culling though, which is strange. Maybe that's part of the problem. Alright, seems like I don't need to put this into a statement anymore. Okay. That's not solving anything. There's the maybe render list. There's the instances to render list, the output. What do we break exactly? Oh, it does a clear, doesn't it, on the screen? That's why. Right, so the reason why the second pass doesn't work is because it literally clears the screen again. So, yeah, so when we do these renders, yeah, so that sort of whole render voxels or whatever, render opaque voxels, it does a clear, so when it does a second time, it's going to obviously clear, isn't it? So, yeah. Right, so found that problem. I guess before we get more of it, running, so we can see it's frustum culling, right? Because if we take a look at the numbers, this 501 that you see here, you move the camera around, see it does reduce when you cover more of it, right? So it's frustum culling. I don't see it occlusion culling though against the occlusion map, which is a bit strange. So if I just look at here, I see this in here. And we see it down samples, right? It's right there. So like, right, if should render, that's right to me. So what the debug box is and all that, right? Let's put this out the way. I need to fix my platform layer a bit. Yeah, it seems like it's infinity from where it's sampling from for some reason. I don't quite know why. Why is it sampling from infinity? What have you done? The occlusion call image is on, right? Then it calls. That should definitely be putting a sync on there. Yeah, sync read write on the... Oh, what are you doing? Yeah, sync image read only. Yeah. So the sync code should be fine. Then you call the voxels. We sync as like a read only on this thing. Wait. Was it syncing as read only in the down sample? What are you doing? Read write. So they might be overlapping. And that's why we're not seeing it work. Or cache is not being flushed. I think that's right. Let's double check it. Yeah, so there it is. Yeah, it's obviously loading and storing from the same base image ID, yeah. So that's all good. Yeah, I can't believe that's been wrong the whole time. That's crazy. Anywho, But that's not fixed the problem. For some reason, we're still seeing like a value of infinity coming back from that image, even though we can look at the image and it seems like it's set to something. If we go to the image viewer, is this guy here, yeah? Now if we there you go. Yeah. That should be, there's like an infinite value you're seeing here. When we're that close, it should be giving us something. It's bizarre. We could have checked the profiler there. But yes, let's get him down here and print out the occlusion depth. It's crazy. So we can check the checking in render doc is probably the next best thing to do. Yeah, what else was I wanting to try? Maybe just render doc is alright. Let's give it a go. Just to make sure my Vulkan code is good. Should be alright. Alright, here we go. So there's a mirror image. Hang on a minute. Right, so there's the render of the scene. There's a dispatch of the occlusion image. And it looks pretty infinity to me. For some reason. What is this one? So it's occlusion call. Ooh, I don't see any yeah, this looks questionable. So there should be it should be in a separate one, right? Because why is there an all commands? When do I do something like that? When do I do an all commands? Command barrier wait, or when do I do that? Right, when there's a profiler. Yeah, when we're doing profiling and stuff, right? But like, what else do we do? Right, when do I do a wait all? So are you telling me that the reason why I'm seeing all those big pipeline stalls is because I got this code is running here, quite possibly, right? Yep, that's true. It is, but it's not even running. Like the profile is not even running right now. So okay. So defaults to no overlap. Okay, it's good to know. So it's not overlapping. So we can profile it. But if we press the V, now they'll begin to overlap. So if we see those downsample image, then there's the cold voxels. You see they start and end at separate times. So they're not really overlapping, but potentially there's not a pipeline. Yeah, so this comes from the profiler, right? Anywho, so if we go to here, this is the occlusion call. Let's look at the pipeline. Should be on the image. The image that we're waiting on is is the occlusion image. Yep, good, good, good. So the so where it was beforehand, it was in a compute shader in a read and write format. Yeah, that's right. Now we want to read it as sample read. So going from a general layout to a read only. Nice. So there is a barrier in there for that. So that's fine, right? So in here then, why does this look funny? Are we meant to say infinity here, but then is that too much? Can I say like 1,000? Right, so we are seeing something now. So this is infinity, but this is something else. So if we said 100. Right, so we see it here. So we downsample. It's upside down because I use origin bottom left, right? Ta-da! It's there, yeah? So you're seeing it. You see it here. And even in this pass here, when you're going over all your models, we look at the inputs, it's the occlusion image, and we look at it here, here it is, it's there, yes? So why does it think? Why are we sampling infinity? Yeah, the image is upside down, so it'll be fine. It was literally working before we did the two pass thing. Right, before we did the two pass thing, it was working just fine. So it's running the same code. Yeah, it's running the same occlusion code base is what I was saying. That has not changed. We can look at the MIP maybe and that stuff, but I don't know. Alright, let's keep debugging it with these print statements and see what we can do. So that's interesting. They're both infinity. So the UV is infinity. So what is occlusion dims then? 0, 0. That makes sense. The occlusion dims is 0. Did we delete that or something some time ago? When, oh when, and why, oh why. So it might have been when I split the code up. Yeah, so I think it's when we made that occlusion cull frame in it and downsample and we split it up. Yeah, there was code which was deleted. Right, let's find it. Hang on a minute. Got to be careful not to save. Where are we going? Somewhere here. So, prepare. It is these guys. We delete these guys. So frame in it, we need to get those. Cool. Well, that should be the problems. Sort it out. Now it should work again. Right, so we're not seeing it disappear, but we're seeing the numbers work out to be fine. You know, if I go to the occlusion call.h, where is it? If should render and. There we go, the box disappears. Boom, that's what we're looking for. So now we move left and right, you see that the last frame depth buffer is causing these voxels to not want to render. And so we need to render the ones which missed a second time around, yeah? So what we can do is where do we do it? So there's a couple of things. So I want to re-enable this, right? So copies the depth after the first opaque render. We copy the depth to the occlusion image again, downsample, then render, then cull them a second time around, then render a second time around. But rendering a second time around means that we actually want to load rather than clear. So we could probably just, I don't know, because if we're doing, yeah, I think we just want to call clear on these targets. Clear visibility. I think we want to, and just make these store. Sorry, load, sorry. Yeah, I think we just want to have a clear targets basically because we want to share this between different renderers. So you probably want to have a visibility buffer clear or scene VB clear. So there is a clear so that will be one of these will do, thank you very much. So in that sort of like, what was it called? The opaque. The clear value is 0. Yeah, good. So scene object visibility buffer. That will just be a 0 value as well. and then you do it again a second time, and that'll be scene depth, yeah? Cool. So that separates the clear out from the render pass, which is not always the best thing to do, but it's just easier to see and manage. When we optimize it, we can change it later. Cool, so it's frozen. Wait for it to... Right, let's see if this has fixed the problem. Right, so we need to make sure they've got this sort of transfer destination because we're using clear operations on them. Yes, when you do it as part of a render pass, I think it could technically be, it'll be free, wouldn't it? Because you're doing it as part of like, maybe it'd be free. Maybe not. I guess it could be free if they've got some special thing in the hardware. But yeah, anyways, this will be fine. So we need to set destination. Here we go. No. What are you doing? Right, so it's using clear color image, right? Trying to clear a depth. There might be a clear depth image, we'll see. Clear depth stencil image. There's a aspect in it. So if the usage of the image has got a clear on it, sorry, it's got a depth stencil. We'll need the depth stencil one because they're different apparently to how a standard image is. Okay, so I guess you're just looking for a dot depth. Clear value. We don't support stencil buffers on my current API. Makes it easier. So obviously the aspect mask is depth. This one down there will be color. So I need to find that, clear depth stencil. That should do it. There you go. Alright, see how that works. Okay, so apparently we're... Right, this is interesting. So it's very hard to see. Maybe we need extra debug things, but we're still seeing this issue. And I think if I were to close it, okay, so it looks like what's happening is there's a first pass, and then there is a second pass, yeah? So the first pass is here, it goes from 0 to 384. And then the second pass is 384 to 511 instances. So, it seems like that is working. It's just, it's not really rendering what we expect to be rendered, right? So, can we can we know if you're on a second pass and do a sort of a debug thing, or that is quite easy to do. I wonder what else we could do. 501. Yeah, so the question I want to ask is, does it work the way I think it works? And by that I mean, if we go to the voxel render setup, we set up these, where is it? Yeah, this instances count, and there's a start index. Is it this plus that? Basically, you know what I mean? Or does it just for loop from here until it gets to this number, basically, you know? Which way around is it? So we want to find that quickly. So let's just ask the AI, be easier. So Vulkan indirect draw command. How does it's called first instance and instances count work? Let's see that. So it's an offset for the first, right? So you would expect it to be like a for loop where you have the start index starting earlier. So right, so okay, it does. It works in the silly way. Okay. Right, so okay. So I did it wrong. Yeah, we need to, that's the issue, is trying to over render and rendering a bunch of crap, I think. So effectively this count is that take that. Pretty sure. Let's try that out. I wonder. Yeah, I think the best thing to do is literally just open up in RenderDoc, you know, because that can capture things, and just gonna make sure we capture the right frame, you know. Plop there and do this, and right, so here we go. So you do like a F12 in it, so that's a good one. Close that. Well, maybe it's not. Right, so there's a second pass somewhere. Culling. 14. Yes, there's the first pass, and it misses these guys. Second pass is right there. So it seems like what we captured was kind of fine. I don't know, like... Right, so these are the other got holes in them. Let's see what happens when we actually get in there, though. Texture viewer. Oh no, look at that. So it's saying it's got no instances. What a shame. So... Oh, this is interesting. So it does the downsample, then it does a dispatch, and what we find out is it's trying to dispatch nothing, right? Am I right? Yeah, 0. That's right. So yeah, the second culling doesn't get anything to dispatch, which is a shame. So why? Oh, sorry, I did a divide like an absolute plonker. It's a divide round up. So what's happening so when you have more than 256 objects, it will kind of work. But if you have less than 256, it's just not going to work at all. So divide round up. Yeah. What do you know? That could be the type of problem when you're tired that you just completely gloss over and not find it. That's why I click no. And here we go. Look at that. Oh, this is amazing. Boom, it disappears, right? And you can debug it by just pressing F1, type in debug occlusion, go down, turn it on, and you can see the frustum. It's still rendering it. Why is it still rendering it? Where are we using the view? I'm confused now. Oh yeah, you gotta render it from the other frame or something like that, isn't it? Sorry. So... Copy depth to occlusion image. You actually need to do this occlusion called debug depth thing, right? So this does need to happen every time. So because you're freezing the camera view and the occlusion texture is from a different camera view, you actually need to render the depth only into the scene VB image, and then it will copy it to the occlusion image, basically. Yeah. But isn't that going to cause problems for when we... So if you're debugging it, you actually don't want it to... Yeah, then think you want to clear out the you probably want to re-clear the scene. Hang on. Re-clear out the depth buffer image again. It's really bad code, but there you go. Does the job. See, when you got that on, you want to re-clear this scene depth back out, so when you render the second time, they'll just all pass. Not really. Yeah, I think you just want to make a copy. Yeah, so I think you want to do a temporary source or whatever, and just allocate it. No, I don't like this. But yeah, you want like an occlusion. Alright, let's not do that. Okay, so we need another one. We can call it the scene occlusion debug. Really, really bad. But there we go. So it could just be a temporary resource or whatever, right? We only instantiate it, render depth voxels, throw it in here. So scene occlusion GFX VK. Right, so the image you want to copy it from in this respect. Cool. And what do you call that? Is it an image ID? Yep. So you say image ID equal GGFX VK, the visibility buffer depth. Yep. But when you have this debug mode on, you want to render it out from the perspective that you've froze the camera at. And then you want to like, that's the one you want to copy it from and throw that into the occlusion image. And then cool. So I think that'll fix our problem basically, that debug view. It's a pretty cool debug view, so we have to keep it running, you know. So here it is there, it's disappeared. We press F1. We've looked for wireframe, sorry, occlusion debug. Turn it on. No. Cannot be allocated when it's already allocated. Questionable. It's being called twice. We could deallocate it. It's being called twice, this isn't it? So I think you want to put that up here. So it's allocated earlier in an if statement still. Alright, here we go. See what's going on. Right, so move that there. Bring up this menu. We'll type in occlusion call, debug occlusion call. So we put that on. We can move the camera around and boom, the thing is not there anymore. Look at that. So effectively what we've done is freeze it to this view here. So the camera's down there frozen. Our camera's up top, obviously. We can press F8. We'll see that this, we have what's known as the, here's that new temporary one we made, right? Let's go to the occlusion image, it's better. So we're seeing it from the perspective of that camera, not R1 basically. And this one down samples and is the one which the occlusion testing is done against. But yeah, cool. Right, so that is the occlusion buffer basically done. So we should now be able to render a big map effectively with this system. There might be some problems for like one frame. There might be an issue. But we can always solve that by like not rendering that frame, which is going to have a glitch, right? Or we could do a sorting pass, which kind of adds problems to like every single frame, unfortunately. Yeah, so I guess we should talk about that problem next. Yeah. So we should probably refactor a portion of the code because we currently only have a capacity of 16,000 instances that are rendered into the visibility buffer. And this is kind of the reason why we went down this route of doing occlusion culling that allows us to actually get down to 16k instances from whatever the game wants to give us. So we're going to talk about that problem and a thing we're going to be solving in just 1 minute. So let's take a quick break and then we'll get back and do a little bit of a refactor. But for what we know is this occlusion culling seems basically done. Super cool. Right, BRB. Yeah, any questions, feel free to ask away, obviously. BRB. All right. So the occlusion culling basically works. So why are we doing this? Why are we doing occlusion culling? Why now? So essentially, we want to render a big map, right? 1 kilometer. I'm not really a fan of kilometers, but we're doing kilometers because we're doing meters. Each one of these bricks is a meter, and if you get right in there, you'll see that they're actually 16 by 16 by 16 voxels. Whoa. I don't know if we're going to keep that. We'll see how dense we want to make them. But that's what they are for now. So each one of these blocks is rendered and it's ray traced into in a pixel shader. And effectively, we want to render a kilometer by a kilometer by 64 meters, right? Maybe 64, we'll see. And that's the map we're aiming for. So the game thread has the map. The renderer needs to render that map. So obviously there's a camera, and you only really need to render a sub portion of that map. Now, the problem is the visibility buffer, right, is basically a 32-bit integer, and we've got to store in there some things. So we go to graphics VK shared. I call it a triangle ref for some reason. That's what it's called. We'll probably rename it. For crying out loud, I keep going to the wrong file. What's wrong with me? Here we go. So it's called a triangle ref. So it's in my code generator file. Anyway. So it's got a kind on there to say whether it's a mesh or a grass blade or a voxel thing. And then it's got an instance index and then a triangle index. So for voxels, this triangle index is going to be a voxel. So we can support a single voxel model, which is just basically a bounding box around it and then you ray trace into it. That can support up to 64K voxels inside of it. So that's something like, I don't know. Well, 64 times 64, okay, it's way too much. So it's probably 32 times 32 times 64, I think. Yeah. So 32 times 32 times 64, that's sort of like the maximum volume you can kind of have. So yeah, maybe it might be good just for us to have 8 voxels in a meter. That way you can support something which is more than a few meters big, basically. And you can render giants. But anywho, basically that's one limitation to do with the visibility buffer. The second limitation is we need to have 16,000 instances. And so that means by the time we render anything to the visibility buffer, we better make sure we don't have more than 16,000 things. Now, that kind of sucks, right? Because the game's like, I want to render a big map. And if you say fit on the screen 32 times 32, and maybe it goes down so many floors, let's say there's 16 floors, it goes down or whatever because the chunk is something like that, you're already at 16,000. Ta-da! Problem. So what we need to do is cull the objects before, make a new list of instances which are basically is in directions. So we have this to render list, it's called instances to render, and it's just a level of indirection. And that's what we output in as part of our occlusion culling, right? If it completely passes the occlusion culling and is not occluded, then it goes into a new list, and that list needs to be less than 16K. If not, you start getting problems where things don't render, which should be on the screen. So what I was thinking we can do is make this back to 16 and swap to 64K, which would be amazing. We can move this instance type into the 2 render array. So we can call it instance type, instance kind, and this can go down here. So instead what we're going to be doing is, rather than making this bigger, we don't make it bigger at all, we just do some special bit packing, and voila, it's the same size, and we can still support up to, you know, as many instances as we need, which would be awesome. So we just need to reshuffle a few things around. So rather than this being a voxel model instances to render, this will actually be an instance to render. No. Yeah, how does the scene shade work? We need to make sure we can get this to work. Scene shade is the deferred shading. Now what makes this great is there's actually layers. So the visibility buffer is one layer, then you can actually get a few more layers when we do an order independent transparency pass. I still need to plug that back in, but that would be really cool. Like when we're doing entities that sit on top of the map, we'll get this working again. It'd be great. But until then, we need to preserve it. So yeah, you need the kind here though, which kind of sucks. So you could have a kind array. Yeah, I don't think you can support it. How would you do it? Because if you had a single array of instances to render, the problem is you have different shaders and stuff. Like you literally have one shader doing meshes, one shader doing voxels, and another one maybe doing grass. And those need to be linear arrays of their own. So unless you filled out a separate array on the side, but then you're just going in there to get a couple of bits out. But you could like squish it right down, right? So you have a buffer, you zero the whole buffer, then you know, awesome bits in there, but it's going to be horrible for performance, and you want to atomic ore it as well and all that. It's possible though. So when you've done the occlusion culling, you can... So you could have like some separate arrays. Nah, it's not worth it. Right, let's stick to 16K. If it becomes a problem, there's still stuff we can do. Yeah, there's still stuff we can do. You know, we can actually reduce that to 15 and do that. And then you actually, then you can support up to 32 squared, right? So 32 squared is currently 2 meters. I don't know, get that way. Yeah. So that's one shift left 15. Yeah, so you could support up to... Yeah, then that supports up to 32,000 instances, which is a lot better to work with. Yeah, let's try that. So let's just shuffle things around for that. So inside here, so 16 times this. So it's 32. then there's that triangle ID thing. Yes, so we actually want to there's something about the voxel cache when you do the upload, I think. There's a thing in there. Here it is. So what we want to kind of say, there's some debug checking code here. We should get that triangle ref and like do some like debug thing, or we try and throw it in there. So it's called a triangle ID set. So we want to do so try and pack it then unpack it basically and see if we get any triangle ID. So the thing is about an ID is that 0 means null. So because 0 means null, what does that mean? So you actually support 32k, take 1. So you need to take 2 instead, and then probably plus 2. So visibility buffer doesn't have enough bits to store voxel count of that. Alright, so that's some nice little checks in there. So if we ever load a model which is too big, let us know. Okay, so I don't know if there's anything else. Yeah, we could look at performance, that could be fun. So why don't we build a big map? Let's just do 1024 by 1024. And then, well, maybe not that big. We'll see. Let's go to the game. So if we look at, let's send something kind of big to the renderer. Let's get rid of that as well. Oh, we want to get rid of the occlusion culling debug stuff, which is going on. Because it's like not useful anymore. And it just prints and then therefore degrades performance. And it, debug draws and all that, so cool. Also in the voxel render setup, there's a couple of print statements. We can now get rid of those. Here we go. Let's go back to the game. So inside the game, we'll have a map dimensions. Let's do 256. Let's say it's got like, let's just do a few layers for now. We can watch the occlusion work, Oh, we filled up a buffer. Alright, so we only just about filled up the buffer actually. So that's the so there is some kind of limit to the renderer, but it's kind of 80. But yeah, we can always make that number bigger. But ideally, you don't want to be sending a lot to the renderer, right? We're going to do chunks in that game sub. 2 seconds. BRB. Just heard something downstairs. BRB. Right, welcome back, everyone. Yeah, it's heard something going on downstairs, so I just wanted to have a look. Right. Yes, was looking at just basically increasing the number of those, the number of instances, you know, so we support up to 64,000 from the game side, but if we can render 32,000 after culling, we might as well support tons more, right? So let's say, should we just support 1 million? Let's take in a maximum of 1 million. 1 times, there we go. So we're going to make it 2 million. Right, so, wait, why are you complaining? Oh, it's got to be changed in 2 places, obviously. Obvious. So, oh, the game kind of decides, does it? No. Payload push. Oh, it's in the payload, is it? It's in a couple of places. Yes, it seems like it's on the, I think it's on... Yeah, it's on the render data array. So it's just not big enough, basically. So game.c, where's the payload queue? So the payload is, you know, a bag of data you just give to the GPU, and then you give that to the GPU, then you get a new bag, and you fill that bag up. You know, that sort of thing. So we look for the payload queue and we instantiate it. It's got 8 megabytes. Clearly not enough. 32 meg, let's go. All the megabytes. Wow. You know, maybe... Yeah, it's quite a lot of data. We just in too big of a map, you know, is it just too big? So it's 256 times 256 times 3, right? Maybe. So... Yeah, then it's multiplied by, it's like 4D, you know? So it's multiplied by whatever the size of this thing is, and I think it can tell me, right? 376. Right, that's like 18 or 64 megabytes kind of thing. Or maybe not. 70 megabytes. Well, it's quite big. Oh yeah, because we have a big old material palette thing. I just thought it would be scalable if I did... Oh, sorry, not scalable. Great for demoing because we can just change the colors of any instance we want. But it's quite crazy. Because that is... 20 bytes, 20 times 16. Alright, it's quite up there, isn't it? That's 320. That's basically the whole structure. Woo. So, you know, we should probably... You know, the game has these material palettes here anyway. It's just you might want runtime ones. These are all sort of on disk. and all that. Yeah, I wonder. Yeah, it would be better for performance if you could sort of share the same materials, but I was hoping for like purposes of like a demo code for us to just upload a bunch of materials. Initially it was 4 materials, that's the thing, but now it's 16 materials per instance, and that makes it a lot of memory. So if we do like, what was the number in this? 256 times 2 times 6 times 4. Then we times that by like 376, wasn't it? Yeah. So if we take that number instead and times it by like, I don't know, what was it, 40 or something? Say 50. That's still 13 megabytes, right? So if we kind of reduce that all the way down to like an integer, which is referenced somewhere else, that's still 13 megabytes of information. Right, let's just do a smaller one. I think today we'll ignore that problem. I want to solve other things, I think, today. Can I make that go to 64 then? Right, so if we see here, it's got like a few layers. If we did this, bring up the F1 menu, go to debug occlusion, turn that on, move that down, and you see there's some of them underneath that are not even rendered anymore because the occlusion buffer culling basically. So it will get rid of some of those layers underneath automatically. Doesn't do a good enough job, probably because the camera's quite far back. It unfortunately can't do down to 1 level. Oh no, it can do 1. You can do 1 in some cases. That's great. So I'm only seeing 2 levels actually, not 4. Okay, so we increase these levels here by a few. So you see here. Now we go up to here. Well, let's just go to here, the default view. We'll turn the occlusion culling debug on. Now we'll change the camera angle. So there's the frustum culling. And then here's the occlusion culling at the bottom. It's doing something. It's not really doing as good as we hope, maybe. Right, can we check that? Where is it? We want to check the occlusion image. Right, so this probably keeps flickering like mad because I think the UI is done on a different frame. Yeah, we want to fix this. This is terrible. So it's different thread. So if you go to the game, you find out that the UI is done here, and it's part of the game logic tick. Now that will do the profiler and the image viewer. Now the image viewer looks over all this whole pool, and wait, does this get cleared at some point? Yeah, it can cause some serious problems actually, because yeah, I think what you want to do is actually give the image viewer. The problem is the image viewer is going to be looking up many. You'll be looking up image information, where you probably want to serialize it and give it to the other thread in a different way. What sort of data is it using? So you got the browser, obviously, and the viewer. Yeah, so you probably want to like serialize that out as separate thing, a separate pool of info. Right, I can't be able to fix that today either. But it would help us in ways. It's just all the temporary resources, they won't really work. But yeah, we're not really doing too much more rendering stuff, that's the thing. If it was doing more rendering, I'll fix it. Yeah, all the temporary resources where they get rendered, we can't click on this stuff and see them at a certain point in the frame. Yeah. Right, something I want to fix is this workflow. This workflow, we press this, and we type like occlusion. Like, yeah. So we've got those three different cameras. We've got the camera the game's going to be at. You press escape. You get this camera. You press escape again. You get the free cam. The free cam's a bit slow. The... And then we can't sort of like unlock it and get the camera back type thing. Yeah. There's a whole bunch of things. So... So... What should we do? So we could probably do... Your escape will allow you to, I guess, quote unquote, pause the game, right? And break out of the locking. Yeah, so you probably want to say like, have a boolean to say whether or not the, whether we want to update the camera or not. Whether we're sort of, I guess you say is paused or whatever. So escape will just toggle is paused, right? Oh, wrong one. That one. Then we want another button, key, where we do F1. And we did kind of notice though, when the other UI is up, yeah, so we don't really want to do this if the game window is like focused, right? So where do we do that? So there was a, where is it at? So in the settings, see even this one, I thought there was an escape key used in here. There is. Okay. But yeah, this one doesn't obey whether or not the thing is focused as well. I think the UI, sorry, the GPU stuff does it. Yeah, Windows keyboard focus. So we want to be doing that. So the issue is you don't know. I don't think you know it while the game is ticking. So like, yeah, I think we can be like off by a frame basically. So the UI gets done here. So we want to know whether or not we can, allow input basically. So that'll be Game. So window, we'll just say is focused, or right, are we keyboard focused on the game? That'll just be a nice thing to have. Cool. So when we do all that sort of like has been pressed stuff, we literally just do this. And that will allow us to respect other things which are open and not steal from that. Yeah, so if I put that in the world overnight, let's put it somewhere. That will do. Right, so if it's paused, now if you press F1, it will allow you to change the camera mode. Then if it's not paused, we want to allow you to move the camera around. And not paused. So the default game camera, we don't really allow you to change anything to the input. Cool. So I think that'll make the workflow a bit better with some of this stuff. So like, if we press, oh no, F1 is that menu. How terrible. I guess F4? Let's try that. Right, that doesn't work, probably because this is not being set to true for some reason. Right, there you works. So you can change the camera. And then if you press escape, it pauses, right? No. So by default, I guess we can trap the mouse. So we just toggle. Show hide toggle. So that will be, so when you start it, start the game, so game logic in it, or game in it, we would like to hide the mouse. Then yep, that's good. No. Right, so it's saying huh. How bizarre. Yeah, so there's a separate event thread basically that processes events. And so we need to send requests for it to do stuff on that event thread. Windows. But yeah, it should be, it's just doing the message queue in it, so. Is window Unicode? Where's that happening? 2416 or 61. As part of the dispatch then, I guess. It's part of this dispatch message. Yes, that's just an invalid name basically. It really means this one. So it calls into there. Does a window get so? Okay, yeah, the window's not set. Probably. There's no window currently showing, maybe. Because the event is something like that. What's going on? Yeah, game in it, and then it's probably not. There's something going on, but the basic idea is Yeah, we could probably... I don't know, where is it waiting for the renderer? The event thread gets kicked off as part of the operating system, so it should be processing it. Yeah, the window hasn't been made yet, that's why. Yeah, the window hasn't been shown. Okay, so maybe we don't lock the mouse right away, that's completely fine. That means it is paused right away. Cool, so why is it hiding? Huh. Right, so why is it by default hidden now? Right, it might be part of the issue with is visible as false, isn't it, by default? Cool, so I think in OS init, we don't set mouse visible to true, and that's been part of the issue with my backend code and why it's got that bug. Cool. We can press escape and it will be this running mode. Nice. And then we can put this debug cam. Should be able to move faster, but there we go. So it's a camera which allows you to move around. And a free cam as well. Cool. Okay. So when we want to do something like, do that debug occlusion, turn it on. We then, we're in here, can do some of this. We can leave it like that, come over here and do stuff. Works much better. Also fly cam. Ooh. Press escape, open up the image viewer, something like that. Oh, that looks weird. Oh, 64 should be the max, shouldn't it? Hmm. Copy. Yeah, they need to raster, that's right. I wonder if it's worth looking at render doc to see if it's... Do we see the depth copy or something like that? Where is it? After the downsample, that looks sensible. So we see this. There it is, up to 64, yes, you move it. Kind of linear there to me. So it's 16, so we see it down here, 16. Smooth. Not sure why my image viewer is doing that then. Image viewer. It's floating point in it. Then the interpret mode would be float. White black. Anywho. Right, so what else can we do in the meantime? Maybe where these cameras start as well. Like, it would be nice if the free cam started from where you actually was rather than at 0, 0. And we probably want to wait to also move the camera around. Yeah, we probably want to wait to move the camera. Yeah, let's do that. It's very useful. So when you change to the free cam, you want the position of the free cam. So that'll be the position world space, I think. Well, actually, no. Yeah, the free cam will be where the. Okay, no, that's fine. It's where you actually pinpointed at. Yeah, that's fine. Yeah, where you're orbiting around. That's fine. I like that. But no. But then you do like camera update or whatever it is. And what does that do? Yeah. But then where is... Oh, it's a camera target position. Right, so target. Oh, for crying out loud, what's going on here? It's a target position. Shouldn't be a thing. But the issue is then, when you move the free cam, you're actually going to be moving the yeah, we'll reset the position. Cool, so we should be able to use the arrow keys then. Where is it at? The nah, let's not set that there. Park camera update. We should be able to use the WASD to change delta in world. Oh, does that allow a rotate? I think so. Oh no, up and down, sorry, that's what that allows. Cool, that's nice. Anyways, we don't... Yeah, maybe we want that. So maybe... Yeah, so move the camera back and then rotate basically. I think we can just get away with we'll see how it goes. I don't think this is going to work, but let's just see what happens. That's going to probably move in view space, isn't it? Yeah, it moves it in world space or something like that. Yeah, yeah. So see, I think we can get this. And we want rotation transform, which then gets set part of this. Okay. Then let's retain a position. Maybe you're okay with just a vector. Let's see if it's okay with just a vector. it was uninitialized memory at some point. Yeah, really bad. Maybe not. No, it needs PP. Okay. Right. So I wonder if you can. Yeah, I wonder how much of this you need basically. Do you just need these two? Maybe. Right, it's just. So camera orbit theta, where it's phi. Then yeah, I don't need you need these translations. I think it's just A and B basically. So that'll be your rotation transform. Potentially wrong. We'll find out. Right, that's sort of working in the right ways. It's just the issue now is that when I push forward, it's going in the. So I think we just need an X basically. I think. Sorry, I need a Y. Right. Because we don't want it to lift up. Yeah, so now it's moving along the ground. So if I press up, it goes up along the ground, right? Then I press, it can go up and down as well. Cool. Right, this one I want to move faster, it's too slow. But it's still working the same. Then that's the fixed camera. This should be locked on the player basically and only stay on the player. Now, where else are we going? The speed of the fly cam. Is too slow. Well, we could double it. It would probably be nice if there was like a shift key basically or something like that. So if you're holding down shift, you get like a times by 2. Or say key mod or whatever, yeah. If left shift is pressed, then speed times equal 2. So yeah, I'm holding shift, now it's fast, let go slow. Amazing. Boom. Still a little bit slow really considering the game. Like the size of the world. So maybe we put it at 12. Because it's still quite controllable at that speed. Right, this is standard speed. Right, you just well, okay, it travels at like okay, maybe it's a bit too fast. you know, I think that's fine. It's just you might want left alt, and then that'll mean that you like go slower. Should we write this stuff down at some point when we know that it feels good? Yes, if you hold alt, it's gonna like slow down basically. Cool. Very nice. Amazing. All right, what's next? So we only really want to do this stuff providing the game window is focused as well. So really, all of this. If the keyboard is focused on the window, please do these things. You know, so you shouldn't be able to, you know, if you're in this update camera mode, but you like alt tab out, it's not going to be moving the camera. Cool. Right, so there is another problem that I want to tackle, because when you go into these modes, like it kind of stops when you reach the edge of the window, and that's just because my platform layer, the way it works, you got to do it a different way basically. So I use clip cursor and show cursor, and when I go to the edge of the screen, it just gets stuck. So it just hides the cursor and stops it from going outside the bounds. You kind of want it to like, you kind of want to do it a different way. Just find out how to do it. So essentially, Win32 clip cursor. Right, so hide show cursor is getting stuck at the edge of the window bounds when using clip cursor and show cursor. Right, apparently it's a classic Win32 synchronization quirk. When the cursor is clipped and hidden via show cursor false, moving the mouse rapidly will cause. Nah, that's not what it is it? It's not moving fast. It's not that classic problem. No. If you're hiding the custom event of 3D looking, using can be problematic because the mouse still collides with the edges of the desktop bounds. That's what I tried to say. But it finally got there. Capping your relative delta values. Instead of clipping it to the window frame, the standard industry practice is to not use clip cursor at all, simply hide it and then snap it back to the center of your window every frame during your update loop. Right, okay. So it's that sort of hacky thing, fair enough. Right, so if you want to integrate this cleanly into architecture, let me know. They're using raw input. Right. Number 3, please. I'm using both raw input and right, see what sort of stuff I can come up with. Using both of them at the same time is industry standard. Okay. When snapping the cursor back to the center every frame, you create an infinite loop. Yes, you have to do like a global boolean basically, you know. Right, so oh man, look at this. Just OOP to the max. No oop, please. Alright. So is looking, ignore X, ignore Y. One way you need to do X and Y individually. So yeah, we ignore that, I think. The center cursor is looking mode. Man. Can you name looking mode to cursor visible? Because it's just like really confusing reading over the code. But anyway. Right, set cursor visible. So while show cursor false. Right, so look, that was when hidden. No, that's kind of dumb. So the teleport's not going to affect this because it's obviously just the window. It's the virtual mouse cursor, isn't it? So this one you want to ignore it. If cursor is not visible. Oh, there's a special ignore mouse X. Interesting. Okay. You could just do a boolean. Basically. But I get the idea, right? So, right, when you hide show the cursor, you just want to not use that clip thing. So, get rid of that clip. So we shouldn't need to clip inside of a window either, and then we can actually just use it. This could work. As we can hide it right away. That'd be awesome. So we can get rid of this. So the request comes from the other side, and we simply right. So on the game side, we should now be able to say is so whereas paused is set to true, and so we delete that and say hide right away. I go back to the Windows side. Cool. So you want to center the cursor. So I guess you do that in a few places. No, you need to do it in one. Fair enough. So you want to do something like this. So if cursor is becoming hidden, Oh, please work with me. Okay. So you get your rectangle. Oh no, you still need the window. So I wonder if you hide it. Yeah, no, we can't do that. Right, let's go to OS. What is it? It's OS internal, I think. Yeah, I'll put that back. Cool. So yeah, we need that handle, unfortunately. So OS to request or something like that. Request. Hide window ID. So the HWND. Nice. So I think we want to say there'll be a boolean somewhere in here. Or we'll literally just say boolean so we could say cursor hide mouse centered, something like that. Yeah, so we just set that to true. So GOS Windows, set that to true right there. Yeah, so we then center it and voila, and that comment is so useful. Cool. You want a good place there. That seems like where we have the where is it? Where we process the mouse move. So WM mouse move. We basically give window tooltip. I forget on tooltips and stuff. Right. So track mouse event is set. What is this thing? Oh, right. But yeah, so essentially you want to say if that global is set, you want to set that global to false. And then return 0. Now the issue is you need to call that like every time it's moved, isn't it? Yeah, I think this code is not necessarily doing everything. Remember to call this at every end of your game loop execution frame whenever it's visible. So, or you could call it every single time. Yeah, hey there, been chilling. Yeah, it is actually. My mother-in-law got it from Kenya when she went to Kenya. My wife is from Zimbabwe, and yeah, she was born there, and then she came when she was like a teenager. But yeah, so that's where this is from. Someone told me the other day it's called a. They told me yesterday. I think it was yeah, I forgot the name of the person now, but it's called dashiki. So dash IKI. And surprisingly, I went to this morning. I went to the butcher's to get like a load of meat. Good times. And the person behind the till, also the people in the back came out and just they asked what my t-shirt was, and I was like, oh, you know, literally just spoke about it yesterday. Um, but yeah, I picked up a load of meat. Got some chicken thighs, got some chicken wings. What else did we get? We got some lamb chops. Lamb is so good. What else? Pork ribs. Can't wait to eat all that food. Eating chicken, amazing. What sort of chicken you got? You got it like seasoned and you know, you got it like in any sauce, like marinated in anything. I'll tell you what, I really love crispy chicken wings. Yeah, you cook them real crispy. Fried no sauce, fair play. Yeah, like you mean like southern fried or just? Hang on a minute. Is it southern fried? Yeah. Or just fried, plain fried? Crusty thick. Okay, crusty thick fried. Not sure I heard of that before, but nice. Been chilling eating chicken. Hmm. Right, so we need to center this thing. You know, we can call it like every time. It will kind of suck. But it solves the problem. Yeah, also we want to like disable. Yeah, there's some obvious problems with this. But yeah, we could probably just select the focus window, right? So a G. Keyword focused. So we could probably just call that OS Windows center cursor. OS Windows cursor hide center mouse. I didn't know GPU needed Hierarchical Z buffer. Thought it was hardware accelerated. No, it is. It's hierarchical depth buffer occlusion culling. I've got occlusion culling written in the title. Yeah, it's occlusion culling. So effectively, you build up a depth buffer of occlusion data, starts from last frames 1. You test all your instances against it, see if they will see if they definitely are occluded, then don't render them. But if they're roughly not occluded, then you're gonna have to render them. And then after that, you've got a new depth buffer for the current frame. You reinitialize that hierarchical depth occlusion buffer thing, and then you look all the objects which failed, and you try and occlusion cull those ones again. And if they need rendering, you render those ones. But yeah, so it's a 2-pass occlusion buffer trick. It's quite popular these days in renderers. So OS, Windows internal. Okay. So now we just need to call this every single frame. So I guess it's along with like that. So you just call it again. It's terrible. But you only really want to call it providing that like a mouse is not visible. How do you even determine that? If the mouse is not visible. If it's on a queue, doesn't it? Restricted to being used by the OS backend event poll thread only. So there's a boolean in there, right? Boolean. Sorry, vert mouse is visible. Is hidden. So if it's not hidden, now you only want this in the Windows backend. Yeah. Right. Yeah, you see, I feel like you got like, you shouldn't be able to set the packet directly in here. It should all be done through yeah. So this should set GOS Windows virtual mouse cursor is hidden. But I think we've got to set... Yeah, so there's an event thread which comes back. And I think, yeah, we want to add vert mouse shown hidden. So we'll need those different events. Oh, it's getting time. OS internal. Alright, vert mouse. Shown. Hidden. These are called by the backends basically. Yeah, cool. So effectively, when that request happens, you want to signal that event. Then when you hide the window, you also want to say it's been now shown again. So yeah, this will call hidden. Right, that'll call yeah, I don't think this. So if it's not hidden, we just return. But anyway, when it's hidden, we recenter it every time. Cool. Then what else do we do? So in OS internal, when we mouse hide or whatever it is, it's only on the focus window. Yep. And if there wasn't, if this is null, we just don't do it, right? Yeah, so in OS. So we only do this if we have, right, if we have Something like that. Yeah, I feel like this boolean here should probably just be an OS internal as invert mouse is hidden. Then that way we can move it inside here. False, then true. Right, so in os.c, there's a place where these get processed. So to read back, basically, mouse shown. We don't really need to do anything. I don't think. Yeah, we do. We need to say that GOS packet. So now it's not visible. Sorry, it is visible. Lovely. Okay, what else is left to do? So when this sort of like mouse hidden and stuff changes, right, let's see what happens when we run it. Okay, so we press escape. Absolutely nothing happens. No. What is going on? So let's have a look. What build system? So I built a little build system in C. So it's like a few thousand lines of code, and basically it just builds a dependency graph like a DAG, and yeah. So what's the best way I can split? Well, on the YouTube channel, I did build it on stream some time back on the live section. But basically, to give you the quick TLDR, it uses Clang to get the .d files, the dependency files, and then it builds like a dependency graph and executes it, basically. And then that's not that long. It's manageable. So it will automatically build all files that I can do like wildcards and stuff. This could be a better API, but it's fine. It works for now. It's painful enough to add files, and that's what we want. Adding files is bad to a project. But yeah, I can always add more shaders. It picks stuff up automatically. I can add more voxel models. It picks them up automatically, runs the builder for it. So the best thing about this system is it just runs in the background. And whenever you change a file, it literally sends the game a message. And the game goes, oh, you've changed the file, I'll reload the shaders. Oh, you've changed an asset, I'll reload the assets. And so it's got hot reloading, and the build system communicates to the game. So it's pretty cool. Pretty handy. Does it handle multiple compilers? No, because I don't really need it at the moment, but I can always extend it to do that, right, if need be. No, it does shaders and game logic as well. There is a bug or two that I still need fixing, but it does do it. Like up to 10 times, I think, and then it doesn't do it anymore. But yeah, I need to, with hotcode reloading, you need to track down bugs. That's the way it goes. But yeah, so we do the sort of hide toggle thing and oh, it's using the packet one. Silly. Right, maybe that'll do it now. So press escape. No. My friend, what's going on? Oh, for crying out loud, I looked in the packet, didn't I? Also, why am I looking in the packet? Yeah. Silly. Trying the debugger again. Oh no. I was looking in the stupid packet again. Silly. So if null you want that to return as well, I think. Make it safe. Right, so press escape. It's hidden. Look at that. So if I press F4, no, all the deltas are messed up. No. Pretty close though. So yeah, I don't know why that's happening, but it's pretty close. Okay, so we're in a good place now. I've got the occlusion culling basically working. So next stream, we want to get a bunch of chunks of things. We want to build the, from the game side, we want to build the tile map system, if you get what I mean, or the voxel map, that's the one. With chunks and stuff, right? Fill up an area and then sort of like frustum cull it and only send the frustum culled chunks to the renderer, basically. And maybe we should yeah, we'll see what sort of algorithms we want to do there for that one. But yeah, then from there we've got a map that we can literally like start procedurally generating, and then we can have some fun there. All right, lovely. So we'll be starting that next stream, Sunday, 7:30 p.m. GMT +1, same time on Tuesday as well. I have one on Thursday usually, but this, this coming Thursday and Friday, I won't be streaming because I'll be away, basically. But I'll be back the following Sunday. So yeah, I'm here next Sunday, this Sunday, this Tuesday, but I can't make next Thursday and Friday stream. I'll post about it on the Discord. Speaking of on the Discord, there's a Discord channel. I'm going to come chat in the meantime. And there's also a there's also a YouTube channel. I'm going to come and watch the there's a video about the game that we're making, basically. You can check it out on there. and I'm hoping to post more stuff on there somewhat regularly, depends. And thank you for everyone who supports the channel. Appreciate you all. You can support the channel and get access to run the code on your own local machine. If you follow the link there, all the information in a lot more detail is over there. But yeah, thank you for everyone who's supporting the channel. Appreciate you all who's shown up. And yeah, check the stream down below. Sorry, the schedule down below for when the stream is in your time zone. Right, catch you later, guys. Have a good weekend, and I'll see you all Sunday. Bye bye. God bless you all.